In this example, we are to find the asymptotes of the function f of x equals 3x cubed minus 4x squared plus 1 over x squared minus 2. Let's start with the vertical asymptote. The first step in finding the vertical asymptotes is to rewrite the function in the lowest terms. And that means we need to factor both numerator and the denominator. Now those two polynomials are not readily factorable. So how do I do that? Well, we'll have to use the techniques that we learn in the lesson about the polynomials on how to factor a polynomial. So let's look at x squared minus 2. If you remember, if we know that if c is a 0 of the polynomial, then x minus c is a factor. So what we'll do is we'll find a 0 of the polynomial x squared minus 2, so make it equal 0, solve for x, and the solutions are plus or minus square root of 2. And therefore, the polynomial x squared minus 2 will factor as x minus square root of 2, first 0, times x minus the second 0, which will be come plus square root of 2. So I know how the denominator factors x minus square root of 2 times x plus square root of 2. To reduce to the lowest terms, I need to figure out whether the numerator has and the denominator have common factors. So I actually do not have to factor the numerator. What I have to check whether x minus square root of 2 or x plus square root of 2 are factors of that polynomial. So how do I do that? Well, they are factors if square root of 2 or negative square root of 2 are zeros of that polynomial. We can check that easily by plugging in the values. So for example, if I plug in the value square root of 2, I will have 3 square root of 2 to the third power times 4 square root of 2 to the second power plus 1. And if I perform the exponentiation, I will get 3 times 2 square roots of 2 minus 4 times 2 is 8 and plus 1. And this is not going to be 0 because the first number 6 square root of 2 is irrational and the other one is negative 7. So those cannot be 0. And therefore x minus square root of 2 is not a factor of that polynomial. In a similar way, we can show that x plus square root of 2 is not a factor of that polynomial. So without factoring, I can say that my function is already in the lowest terms. And therefore, I can go to the step 2 of finding the vertical asymptote, which is simply taking the denominator and equating it to 0, solving for x. And we already done this. The solutions are plus or minus square root of 2. This allows me to write the vertical asymptotes as x equals first solution, which is the square root of 2, and x equals second solution, negative square root of 2. So these are the equations of vertical asymptotes. As for horizontal or oblique asymptotes, we'll have to determine the relation between degree of numerator and the denominator. Degree of numerator is 3 and degree of the denominator is 2. So this means the degree of numerator is more than degree of the denominator, so there is no horizontal asymptote. However, the degree of numerator is 1 more than degree of the denominator, so there is oblique asymptote. To find the oblique asymptote, we have to divide numerator by the denominator. So let's do that. We have to use long division process because the degree of the divisor here is more than 1. So we'll have 3x cubed minus 4x squared. I will place 0x term as a placeholder plus 1, and I want to divide this by x squared minus 2. Dividing the leading coefficient of the dividend by leading coefficient of the divisor will give me 3x. Multiplying 3x by the divisor is going to give me 3x cubed minus 6x. We'll subtract those polynomials. Subtracting means changing signs to the opposite and adding. So the difference is going to be negative 4x squared plus 6x plus 1. Now dividing leading term of that polynomial, negative 4x squared by x squared, is going to give me negative 4. And multiplying back will give me negative 4x squared plus 8. Subtracting those two polynomials, change the sign to the opposite and add, will result in 6x minus 7. Since 6x minus 7 has degree less than 2, this is our remainder, and 3x minus 4 is our quotient. And therefore oblique asymptote for this function has the equation y equals quotient in the division, which is 3x minus 4.